This section is on inverse functions. A function is one-to-one if any two different inputs in the domain correspond to two different inputs in the range. So basically, if we look at a picture, let's graph it. This function is not one-to-one because there are more than one y values for a single x value. And we'll talk more about that in a second. Added to that is, what is an inverse function? If a function is one-to-one, then the correspondence from the range of f back to the domain of f is called the inverse function of f. And we denote that with f to the -1 power. Now, that is not an exponent, okay? So don't get confused there. It's just how it's written. So the -1 is not an x power, that exponent, that is just denoting inverse. We can use the horizontal line test to see if a function has an inverse. So this function was not one-to-one. It does not have an inverse because if we draw I looked at the wrong thing. Okay, so this function does not have an inverse because if we draw a horizontal line through it, it hits more than once. Now, why does it not have an inverse? Because if we were to graph the inverse, it would look like this. This is not a function because the vertical line test doesn't pass. So a function cannot have an inverse that is a function if it doesn't pass the horizontal line test. Okay, for example 1, determine whether these are one-to-one. So if we look at this, there are two values where there's two x's going to the same y value. So that means it is not one-to-one, which also means that this function, this function would not have an inverse. Let's look at these. Will these have inverse functions? If we do a horizontal line here, no. Yes, this is a function, but it will not have an inverse that is a function. What about part B? If we draw horizontal lines on here, we're good. So yes, part B has an inverse. A does not. How do we find the inverse of a function? Well, if a function has the points x, y, its inverse will have the points y, x. You just switch the x and y values. Okay, so we'll go back to that in a second. So if we've got this function here, we want to find out if it has an inverse that is also a function. So first, we're asked to find the domain of this function. The domain are the x values in order. Looks like they're already in order, so that's good. -3, -2, -1, 0, 1, 2, and 3. The range are the y values, -15, -10, -5, 0, 5, 10, and 15. Okay? So, it asks, what is the inverse then? Well, what we do is we just switch the x and y values. So the point -3, -15 becomes -15, -3. The point -2, -10 becomes -10, -2. -1, -5 becomes -5, -1. 0, 0 is still just 0, 0. 1, 5 is 5, 1. 2, 10 is 10, 2. And 3, 15 is 15, 3. Now, what's the domain of the inverse and the range of the inverse? Well, it's basically just the other ones switched. So the range of the inverse are the x values of the inverse. And if you'll notice, the domain of the inverse is the same as the range of the original function. The range of the inverse are the y values of the inverse, and the range of the inverse is the same as the domain of the original function. Okay, back to our definition. A function has an inverse, two functions are inverses of each other if you can combine them and they both give you x. So if you take the composition of f and g and it simplifies to x, and then you take the composition of g and f and it simplifies to x, then you know that those two functions are inverses of each other. And we'll come back again. Let's look at example 4. So, show that these functions are inverses of each other. So we're first going to find f of g of x. So wherever there is an x in f, we're going to plug in x plus 7 over 4. So 4 times x plus 7 over 4 minus 7. And then we simplify. So if we've got 4 times x plus 7 over 4, the 4's cancel out and we have x plus 7, then our minus 7, we get x. So far so good. Then we'll go and find g of f of x. So everywhere in G, where there's an x, we're going to plug in 4x minus 7. So in that first x, we plug in 4x minus 7, and then we have plus 7, all divided by 4. So you can see minus 7 plus 7, that cancels. We get 4x over 4, which is x. So we know that, yes, these functions are inverses of each other. Next, if we have a function, how do we find its inverse? Well, we said back with this example that if we switch the x and y values of the points, then we found the inverse. Well, it's the same thing with the function. If you switch the x and y values and solve for y, then you've found the inverse of the original function. So let's try a few of those. So we have f of x equals 2x plus 7. That's the same thing, remember, as y equals 2x plus 7. So to find the inverse, we plug in x for y and y for x and solve for y. So we've got 2y equals x minus 7, divide by 2. And so the inverse function, denoted by f to the negative 1 of x, is x minus 7 over 2. If you wanted to test that, then you could do f of inverse of x and f of inverse of f of x, and yeah, make sure they're both x, and it would be all good. So try this one. So here we have y equals x plus 1 over x minus 2. To find the inverse, we put x in for y and y in for x. Excuse my cat meowing. He wants to go out, but it's too late. Yes, he should have gone out earlier. So, multiply by y minus 2. We're trying to get y by itself here. Go ahead and distribute the x. And then we need to get the y's on one side and everything else on the other. So I'm going to subtract y from both sides. So I've got xy minus y on the left. And then add 2x, so I have 1 plus 2x on the right. So to get this y by itself, we need to factor it out. And then we can divide by x minus 1. And we have our inverse function. 1 plus 2x over x minus 1. And then one more example like this. Again, we have y equals x squared plus 1. Oh, let's go back and point out something real quick. This is saying where x is not equal to 2. So the inverse cannot be equal to 2 either, or it won't work. And then this one is saying where x is greater than 0, and we'll see why here in a second. Okay, so switch x and y so that we have x equals y squared plus 1. And subtract 1. And take the square root of both sides. Now notice I didn't put the plus or minus. Because we're only focusing on where x is greater than 0 here, then we're only focusing on where y is greater than 0 down here. If I were to graph these, the original looks like this. Its inverse looks like this. So the reason why we can only have x greater than 0 here is because to also have a function, we can only have y greater than 0 down there. If we did both halves of the y-axis, then we wouldn't end up with an inverse that was a function. So this is the inverse function, just positive square root of x minus 1. And then let's point out that we've already talked about this a little bit. Since we're switching the x and y axis, x and y values, then our graph of the inverse is actually a reflection along y equals x. So, for example, if we have y equals x graphed, and your original function looked like, oh, that's not a function, like this. Trying to make this too hard. Let's say it looked like, oh, I don't want that to look horizontal. Okay, let's say it looked like that. Then its inverse would, all those points would be reflected to look like that. And so we are going to look at an example of this. So to plot the inverse, we are reflecting about the line y equals x. And just like we've been doing, we switch the x and the y. So this point, the point -3, -2, becomes -2, -3. The point -2, 2 becomes 2, -2. The point 4, 1 becomes 1, 4. And the point 4, 3 becomes 3, 4. And so your inverse function looks like this. Well, it's not a function, but the inverse relation looks like that. Okay? And that concludes this on inverses.